Hello. So in this topic, we're going to look at trigonometry, and actually, this topic is basically all GCSE, which I guess some people may be relieved. If you're further into the course, you'd be glad to know it's all basically knowledge you already know. But with that in mind, what I always say, even with these sort of earlier topics, always look at them still because the questions will be a bit harder to an A level standard. And that's what we'll be doing, right? Is going over some examples, as always. But then, so we're first going to look at the cosine rule, and this is if we have any triangle, oh, any general one, say we put a non-right angled triangle, could be right angled, but generally a non-right angled triangle with points A, B, and C. So a general triangle. If we know an angle, say at A, and we know the two other sides, say this is B and C, then we can find the other side, which we call A. Now the other side is going to be opposite the angle we know. So in general, we have an angle and two sides. However, the missing side is the side opposite the angle. Okay, as you can see here, the angle facing the side. Okay. Now we can find that other side A by saying A squared is B squared plus C squared minus 2BC cosine of A. Right, and that is the cosine rule. Now, you do not get given this in A level. I don't think you should be at GCSE as well, but I think for GCSE with the COVID support, I think you might got getting the formula, but you do need to know it for A level. You won't get it's not in the formula book. But that's the cosine rule. Right. So the main idea you need to know is this is for when you know one angle and the two sides and you want to find the opposite side, right, to the angle. Okay. Now this might sound a bit weird at first, but when we go over some examples, hopefully it become quite clear when exactly how we use the formula. But yeah, the other thing to note is we can rearrange it. Say instead we know all three sides instead, A, B, and C, and we need to find a missing angle. Say again at A, this angle here, the angle at the point A. We can rearrange this equation to rearrange for A, right? So the angle A, okay, so cosine of A. So if I want to rearrange for cosine of A in the subject, well, firstly I need to take away B squared and C squared. So therefore, A squared minus B squared minus C squared is minus 2BC cos A. And then hopefully you can spot then that therefore cosine of A is going to be dividing that by minus 2BC. So A squared minus B squared minus C squared over minus 2BC. And we can simplify that because we can take a negative out. So I can factor a negative out here and say this is negative B squared plus C squared minus A squared over minus 2BC, and then I can cancel the negative out, right, and I get that's simply B squared plus C squared minus A squared over 2BC, and that is cosine of A. Now if you want to find the angle A, then obviously you have to do inverse cosine. So this formula gives us a way, if we know all three sides of the triangle, to find an angle. Okay, and so I'll say this here. This tells us the angle given three sides. Okay, so those are the two sort of cases we'll be working with in this section, in this video, where we got two sides and an angle, or all three sides essentially, right? And so that's the other formula. Now, again, you don't get given this formula either, so you got a couple of choices. You could memorize both, or you could kind of memorize this one of them. Probably this one, probably the best one, and then you can sort of quickly rearrange to get the angle. Okay, or really you can kind of just substitute the values in and then solve the cosine of A. So you don't really need to rearrange it per se. But we'll see for some examples how we use the formula, right? But those are the two formulas we'll be working with. As for proving it, you don't need to prove it. I've checked the spec. You only need to know how to use the formulas. But if you do want to know how, I'm not going to go through it here to save time. But the textbook does it. Sure, there's loads of videos that does it. But the idea behind the proof is, or one of the ways of proving it is, obviously take your generic triangle ABC. Then basically you want to construct a perpendicular height, right? As so. And then you got two right angle triangles, triangle 1 and triangle 2. Then you can sort of, and you call this height H. Then you can sort of find different ways of, you can use SOHCAHTOA to express, to get different equations, to then get the equation, the formula, right, that we know. But there we are. Okay, so let's jump into some examples then. Okay, let's have a look at this example. Calculate the length of side AB of a triangle ABC in which AC is 6.5, BC is 8.7 and ACB is 100. So this sort of question where it's describing something geometric, like a triangle, but they don't draw anything. It's best to do a little sketch, a little drawing, right, yourself. So let's say we have a point A then B says over here. Not done any points in particular, just done points there, right? A and B, and then A to C, say there, again, and so then if we connect them, there we are. So then A, B, we need to find AB. We can call that X if we want, but it's up to you. Then we have AC, which told us 6.5, and BC is 8.7. So it's a bit off the sketch, right? It's not really the lengths aren't really like representative, but it doesn't really matter. We also told the angle. Now this notation, this weird sort of like almost nose. Hang on, there we are. Almost like a pointy nose. ACB. That's telling you this symbol means angle. I'll say that here. Angle, and an angle ACB. Now we label angles with 3 letters. The middle letter, we go in alphabetical order, so A, B, C, but obviously C is in the middle because the middle number in an angle is where the angle's at. So that means C is in the middle, so it goes from A here to C to B. So the angle is going to be there at C, okay? So that's how we do angle, that's how we express angles. So this weird pointy nose shape means angle. And we label the 3 points in alphabetical order, but the point in the middle must always be where the angle's at. Anyway, so C, we're told the angle is 100, okay? Degrees. So then we need to find AB. Now again, we can use the cosine rule because we know an angle and 2 sides. So then we can find the opposite side, AB, to the angle. So then that means, remember the cosine rule, A squared is B squared plus c squared minus 2bc cosine of a. Now, a squared is ab, so that's going to be ab squared. And then b squared is, well, one of the sides, right, 8.7 squared. And c squared, well, the other side is 6.5 squared. Then we take away 0.5 times by cosine of the angle 100. Right. And so therefore, we're just basically putting that in the calculator then. So, we get AB squared is, well, 8.7 squared at 6.5 squared minus 2 lots of 8.7, 6.5, cosine of 100 gets me 137.579 dot dot dot. So then to get AB, I simply need to square root it then. So therefore AB is going to be square root of 137 point dot dot dot. And I get 11.729 dot dot dot. Does it say to get, does it say to round it to anything? So I'll just say 11.7 to 3 significant figures. Okay. Right. Let's have a look at this example. Find the size of the smallest angle in a triangle whose sides are length 3 centimeters, 5 centimeters, and 6. So again, let's kind of draw a triangle then. So firstly, here, let's say this is point A and point B. That's 3 centimeters, right? Then let's say B to C here is 5. Then A to C would be the other side, which is 6, okay? So just sketch the information, basically. Sketch this triangle with these lengths. Now, the smallest angle. Hopefully you can spot from the sketch that it's going to be this angle here. That looks like the smallest angle. And the smallest angle basically faces the smallest side, essentially. So that is where the smallest angle is. Alternatively, you could find all 3 angles, and then from that, obviously, then you can deduce the smallest one. But that might take a bit of work. But hopefully you can notice on the sketch that this will be the smallest angle, and it's the angle facing the smallest side. So this is the angle we're going to be working with at the angle at C here. Well, then we need to find an angle, but we know all 3 sides. So, this is the cosine rule. Now, you could rearrange and use the cosine, the angle version of the formula, but I'll show you kind of really why you don't need it, because I can just substitute the values in and then sort of solve for cos A. Well, A is so cosine of A is the angle we're working at, but then what's the side that's facing the angle is the AB, which is 3. So that means the little a squared is going to be 3 squared. And that's going to equal then b squared and c squared, which are the other 2 sides. So that's going to be 5 squared, add 6 squared. Take away 2 lots of 5, lots of 6, lots of cosine of... well, it's not, I'm not going to use the letter A. It's going to be the angle at C, right? There we are. So then we just need to simplify this, right? Solve for the angle C. Or could call it theta, I guess. Probably the more typical way of labelling it. So we need to solve for the angle theta. So, well, 3 squared is 9. And then 5 squared and 6 squared. That's going to be 61. Take away 2 lots of 5, lots of 6. So minus 2 times 5 times 6 is minus 60. Cosine of theta. So then I can just get cosine of theta then. So then 60 cos theta is 61 take away 9, which is 52. Therefore cos theta is 52 over 60, which is going to be 29. If I inverse cos that, I get 29.9 degrees to 3 sig fix. And there we are. So yeah, that's the whole idea with these two examples. Right? Hopefully you've seen we can use the cosine rule if we know two sides on an angle, like in the first example. Here we can find the other side, and alternatively, if we know all three sides, we can find a missing angle that way. So yeah, so the crucial detail is really recognising that the angle we want will be facing the side. Okay. So this cosine of A has to correspond to that A there. So the angle, the opposite side is the 3 in this case. But anyway, let's have a look at another example. Okay, so this is now including bearings. Hopefully you remember from G2C. But it says Coast Guard Station B is 8 kilometres on a bearing of 60 degrees from Coast Guard Station A. A ship C is 4.8 kilometres on a bearing of 18 degrees away from A. Calculate how far C is from B. Right, so again, we kind of want to sketch the situation where the points are, but it includes bearings, which are basically angles. Well, they are angles, but they work slightly differently to typical degrees, right? Typical angles. Now, bearings, there are two key points. If we're measuring from a point A, say, and then we have a point B here, we measure the bearing is the angle from the north at A. So when it's completely above A, and then how far, and then this angle here is the bearing, which is theta, right? So yeah, so if we start from a point A and then we move to somewhere else, we need to measure the angle from sort of upwards here in like the north direction. The other point is that bearings are always in 3 digits. Now that 3 digits, that's not too troublesome, because hopefully you recognise 060 means 60 degrees, right? But that's the other thing. Bearings are also always 3 digits. If there's a 2 or 1 digit, like if we had 9 degrees, we would say it's 009 degrees, right? In bearing. But the main idea is, with bearings, you measure from the top and then you sort of rotate, and then that's how we denote the angle. With that in mind then, so let's sketch the situation. It's talking about a station B is 60 degrees from A, and a ship C is is 18 degrees from A. So let's say A is here, very generally. Then first of all B. Now B is 8 kilometres on a bearing of 60. Now first let's deal with the bearing part. So again, if we measure if we start from the north direction upwards, right, then the bearing is 60 degrees away from there. So it's probably going to be about there, right? That's going to be 60 degrees away from that line, the north line, right? So then we can simply continue this line. And that'll be the point B there when it's reached 8 kilometres. There. Okay, cool. So that's where B is. Now C is a bearing of 18 degrees. So 18 degrees, again from the north, the same north direction, upwards. 18 is probably going to be like about maybe like there. And that'd be C. And 4.8 if I say 8 is down there, 4.8, let me write a bit clearer. I've got much space to write this actually. 4.8 kilometres there, okay. Right, okay. Then it's asking to calculate how far C is from B, so it wants this side here. Okay, So this is 4.8 and that's 8. Okay. Right, so this is 18 degrees then. This little weird like wedge between the north line and the line AC. Now, we have a triangle. Hopefully you recognise I have a triangle here. ACB. And AB is 8 kilometres and AC is 4.8. And we want to find this length CB, right? We can call that X if you wish. But I need an angle. Because it's talking about angles, I can get an angle. But I know that again, from this top, look, this is 18 degrees. But I also know the whole angle here is 60 degrees because that's the bearing to be, right? So therefore this angle in the triangle, well, that's just going to be 60 take away 18. So I can say angle BAC is going to be 60 take away 18, which is going to be 42 degrees, right? So therefore then I deduce that this angle in the triangle, angle BAC, is 42 degrees. So now I've got an angle in the triangle. Cool. Right, so I think that's probably the hardest step actually, is working out the angle. So hopefully you kind of understood that the bearings. Again, because the whole angle from on this north line, the whole angle here has to be 60. But I also know this angle here is 18. So therefore, to get this angle inside the triangle to add up to 60, I need to take away 60 from 18 to get 42. Anyway, so there we are then. So we've got this triangle then. So again, it's at this point, it should be a fairly standard sort of cosine rule problem. Because now we need to find the missing angle x. And we know an angle, and well, this side we know as well, 4.8. We know two sides and an angle. So we can work out the side facing the angle, because then that side is x squared. And so then, remember I'll reset the cosine rule. A squared is b squared plus c squared minus 2bc cosine of a. Now, a squared is cb, is x, right? That's the missing angle that we want to find. So then the other two sides, b and c, say, is 4.8 squared add 8 squared minus 2 lots of 4.8 times 8 times by the cosine of the angle 42. And so if we put all that in the calculator, well then x squared is going to be 4.8 squared add 8 squared, take away 2 lots of 4.8 lots of 8 lots of cosine 42, and I get 29.966 dot dot dot. So then therefore to get x, then the angle, the length CB BC, I need to square root it, and so I get 5.47, right, kilometers to 2 decimal places. And there we are then. So that's how far C is from B. Okay, that's this length there. Cool. So again, you are expected. We'll see another bearings question later on. But yeah, you do need to know bearings as well. But hopefully you kind of understood. Hopefully that was a good refresher. And you understood why I got the angles that I did, and how I got 42 there. Other than that, it should be a fairly sort of straightforward cosine question once we've got the triangle, right? But there we are. Let's have a look at this example. We are told in triangle ABC. By the way, this notation as well seems a bit weird, just drawing shapes. But this literally means triangle ABC. Okay, don't be thrown off by that. But triangle ABC, AB is x, BC is x plus 2, and AC is 5, and angle ABC is 60. Find the value of x. Right, so it's a bit of algebra thrown in. But again, so it's talking about a triangle. Let's kind of sketch the triangle. Well, not sketch, but do a very rough idea of what the triangle looks like. So we have triangle at the point A, say this is the point B and then that's the point C. Right. So then we're told AB is X. We're told BC is X plus 2. And we're told AC is 5. We're also told angle ABC, so that will mean the angle at B then, because B is in the middle here, so angle at B is 60. Then I need to find the value of X. Right. Now, again, don't be thrown off by the algebra, right, letters. You do the exact same idea with letters as with typical numbers, right? The same old, the same way of doing things. So what can I do here then? Well, again, I do know all three sides and an angle, so I can apply cosine rule here. Okay. Well, the 60, the angle I have is opposite the 5. So that means we're going to have, well, firstly the cosine rule is a squared again, plus b squared is c squared minus 2bc cosine of a. I'm restating that so it kind of drills into people's mind. But then, because the angle here is 60 facing the 5, that means we're going to have 5 squared is equal to the other sides squared, so x squared, and then the other side is x plus 2 all squared. Take away 2bc, so it's going to be 2x, lots of x plus 2. I need more room here. Cosine of 60. Okay, there we are, to squeeze it in. There we are. Okay, so we get this equation. So then I can start to simplify some stuff, right? So 5 squared is 25. I'm going to do that. I'm do that down here. So 25 is x squared. Now x plus 2 all squared. I need to expand that out. If I expand that, I get x squared. 2x or 2x is 4x. Then 2 squared is 4. And then I need to deal with this bit. So firstly, minus 2x times x plus 2, that's going to be minus, well, no, firstly, cosine of 60 is a half, right? So it's going to be minus 2 times a half times x of x plus 2. Okay, let's do it step by step, right? So then 25 is x, well, then I can collect the like terms here. So it's going to be 2x squared, add 4x plus 4. Then minus 2 times a half is just minus 1. So simply get minus x lots of x plus 2, which is minus x squared minus 2x. Okay, there we are then. So then I can move this 25 to the other side, because I notice this is a quadratic equation. So then I can collect all the like terms again. So 2x squared and minus x squared gets me plus x squared. Then 4x minus 2x is plus 2x. Then I have 4, and then I'm taking away 25 because I'm moving it to that side. 4 take away 25 is minus 21 equal to 0. Right, so that's in a quadratic equation then. So we can then solve that for x. So then x is going to be minus b, so minus 2, plus or minus square root of 2 squared, minus 4 lots of 1, lots of minus 21, over 2 lots of 1. And so if I put that in the calculator, I get x is minus 1 plus or minus root 22. Right, okay. And so if, no, it doesn't seem to round it to anything. So, we've got 2 solutions here, but it's only talking about one solution. Now, actually, if I put this as decimal, well, firstly, minus 1 plus root 22, that, the calculator tells me that is 3.69 something. Or, if you have minus 1 minus root 22, so do the minus case, that is minus 5.69. Now, we can never have a negative with stuff to do with distance, right? X is a distance, it's a length, so it cannot be negative, it has to be positive. So we can't have that. So x is positive as it is a length. Therefore, x is going to be 3.69, right, to 2 decimal places. If you were a bit unsure, you could, I'll just give it in exact form. So I could say just -1 plus root 22 in exact form. Meaning a form that has no decimals in its in precise form with surds in. Okay, cool. So hopefully start to get hopefully it's a good refresher, reminder from GCSE. And yeah, and also don't be thrown off by the algebra as well. Again, we're doing the same sort of stuff, right? But throw the letters in. Hopefully it's not too weird, right? But there we are. Let's have a look. Okay, we've got some further exercises. So here we are told a farmer has a field in the shape of a quadrilateral shown below. The angle between fences AB and AD is 74. We can kind of, we got given the diagram actually, so we can sort of annotate it, if you will. Well, AB is here, and AD is that side. So the angle between them is 74. That's what we're told. I'll tell you what, I'm going to make a bigger diagram myself. So I'm copying what they're giving me, but making it a bit more, a bit bigger. So AD, CB. Now AB is 120, AD is 75, 135 there, and 60 here. And I'm told the angle here between AD and AB is 74. Then it says to find the angle between BC and CD. So it's going to be that angle here, right? Between BC and CD. I can call that theta. So I need to find that. However, how am I going to do that? I don't have a triangle. It's just a quadrilateral. This is where you have to be a tiny bit creative and create triangles. So probably the most by far the most apparent way of doing that is just to create a diagonal, right? So therefore I've got 2 triangles. Right. Now I can't. Now this is where you got to kind of think about the information you have, right? Because I can't find theta at the moment because I know 2 sides on that triangle, 35 and 60. But remember, if I need the cosine rule, I either need I need to know 2 sides and an angle that's known, or 3 sides that are known. I don't know 3 sides and I don't know any angles, so I can't use that on this triangle up here. But what about this triangle then? The other one. Well, I know 2 sides, cool, but I also know an angle, so that makes me eligible to use the cosine rule. Again, I'm going to restate it here. A squared is b squared plus c squared minus 2bc cosine of a. Now, what am I going to use exactly? So, I can find the other side, right? And that side is going to be facing the angle here. So I'm working out the side db. I'll call it x again, right? So I'm going to solve for x. So then, as x then, db is facing the angle, that means x squared is going to be the other 2 sides squared. So it's going to be 75 squared, add 120 squared. So okay, 2 lots of 75, lots of 120, cosine of the angle, 74. So then I just need to put that in the calculator. Well, 75 squared, add 120 squared, minus 2 lots of 75, 120 cosine of 74 is this number here, 15,063.527, no, 5276. Right, so then I need to square root it then to get the xn, so therefore xn is going to be the root of that. It's going to be 122.73 meters to 2 decimal places. Now, because that's not the final answer and I will need that, do I round it? Or do I write the full thing the calculator gives me? I would, well, the answer, The calculator has a store function. So I could just store my answer actually. Which I maybe go into another time, how to use the store function if you don't know already on the calculator, which it immediately instantly stores all the answers, so you don't have to write down long decimals if you need to repeat them, because we will be reusing his answer again. Or you could just write down all the digits if you're worried about any rounding errors and like missing a digit out or something like that. But anyway, this is the angle I get, the side I get. So then I know x then, right? Now I'm in the case where I know this side x, I know this side and this side. Well, now I know three sides and I need to find a missing angle. So again, I can use the cosine rule for that triangle then. So again, the cosine rule is here. Now, I want to solve for theta, the angle theta here. So then the angle facing theta is x. So I'm going to start then with x squared. Now actually I know x squared already, but I restate it anyway. So if we use the formula, it's going to be x squared. It's going to equal the other two sides all squared, so it's going to be 60 squared. Add 135 squared minus 2 lots of 60, 135 cosine of theta. But then I know x squared is 15,000 and 63.5276 is going to be 60 squared. Well, 60 squared is 3,600. Add 135 squared. Well, 135 squared. Actually, I could just do that all in one. Well, 60 squared add 135 squared is 21,825. Take away 2 times 60 times 135, which is 16,200 cos theta. And then I could just solve this for cos theta, right? So if therefore I get 16,200 cos theta is going to be 21,825. Take away the 15,063.5276, which is 6761.4724. So therefore then cos theta, if I divide that answer by 16,200, the number in front of the cos, I get that cos theta is 0.417 ... right? So then therefore theta then I need to do the inverse cos. So then that's going to be giving me an angle of 65.3 degrees to 3 significant figures. Okay, cool. So there we are then. So yes, so sometimes you may not be as straightforward as just giving a triangle. Sometimes, very rarely, you might need to find a triangle, something like this. But hopefully, we could just do the diagonal, and there we are then. So and also the key thing is you might have to work with two triangles like this, where you might need to find information and find a missing side for one triangle, which you can then use to find information about the other triangle. As we did here, we found a side on the first triangle, and then we could use that to find the angle of the second one. Okay, cool. So have a look at some exam questions then. It says figure 1 is a sketch showing the position of three phone masts A, B and C. The masts are identical and their bases are assumed to be in the same horizontal plane. From mast C, mast A is 8.2 kilometres away on the bearing of 72, and the mast B is 15.6 kilometres away from a bearing of 39. Find the distance between mast A and B. Okay, so it's very, very similar to the other example we looked at with bearings. So, first of all, let's deal with the bearings bit. So, first of all, A, from mast C, well, they've given us a diagram roughly, which is quite helpful. but mast A is 72, bearing of 72 from C. Now they've already drawn the north line, right, the upper line. So 72 away from that is probably going to be about there, right? So if I do that, so then that angle's probably going to be at about 72. And then from B, the bearing is 39. So then, if I connect to B then, oh, probably have to get rid of this, apologies. So then if I connect it to B, that angle, that bearing, that angle's 39. So the angle between the north line and the line connecting to B, that angle's 39. Well then it's asking for the distance between A and B, which is this length here. So we get a triangle, right, between C, B and A. So if I draw it here, so that's C, oh, and that's A and that's B. But I also know the sides as well. Between C to A, I'm told is 8.2 kilometres there. And from C to B is 15.6, right? So I can label this here. And I need to find the length between A and B, the distance between A and B, which I'll call X again. But I need an angle. So again, it's about the bearing stuff. So this angle here is 39. But I know the bearing from C to A, the overall angle here is 72, right? Right. So if the overall, hang on, so let me show this again. So if the overall angle here is 72, which is the bearing from C to A, but I'm told the bearing from C to B is 39, which is here, then I can work out this angle here in the triangle. Isn't that angle then, we'll call angle ACB? That's again going to be the overall angle, the overall bearing of 72. Take away this angle 39, right? And so that's going to be, if I work that out, 33. Which I then can put here. So that's where 33 is. So therefore then, this angle then will be 33. And so hopefully you then see 39 and 33 indeed gets me the overall angle of 72, which is the angle from C to A, the bearing there. Okay, so we use that then to find the angle in the triangle. So then we can use cosine rule, right? So the cosine rule, again, I know an angle and I know two sides, and I know this side, and I know this side, so I know two sides and an angle. I can then work out the other missing angle x, and the angle facing that, and the side facing the angle is x, right? So again, if I reset the cosine rule once more, a squared is b squared plus c squared minus 2bc cosine of a. Well, the opposite side is x, so therefore x, we're going to have x squared then, and that's going to equal the other two sides squared, so it's 8.2 squared plus 15.6 squared minus 2 lots of 8.2, 15.6 cosine of the angle of 33. Cool. So then if I work all that out in the calculator, well, 8.2 squared add 15.6 squared minus 2 lots of 8.2 lots of 15.6 cosine of 33. I get 96.0345 ... So then I need to square it to get x then. So then I square root that to get a square root to get 9.799 ... Does it say to round it to anything? Give your answer to one decimal place, and that's going to be 9.8 kilometers to 1 dp. Cool. There we are then. So that's the distance between A and B. Cool. Then it says an engineer needs to travel from mast A to mast B, so i.e. the length we calculated, right, the 9.8. Give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travelled. So yeah, these questions are a bit boring. I can't lie. They're very typical. Usually like thrown to one marker like this with like a real life problem like this. So why would my answer not be realistic? Probably many reasons you can come up with why this sort of triangle is not realistic. The idea is that essentially these are straight lines, right? All these distances they're straight lines between points. Now, realistically, going from 2 points in real life, right? Imagine going from one, I don't know, like one place in a city to another. Are you likely to be going in a straight line? No. I mean, there could be all sorts. There could be like bends in the roads. You might have to go to detours or something like that, right? And simply, things just won't be in straight lines, right? Essentially, the roads might be curved, which would mean it be longer, right? Straight line distance is the closest. Length, but actually the length would actually be greater because, like I said, there'd be curved roads which will stretch further. Because roads aren't perfectly straight, right? There might be there might be detours you might need to take throughout the route, which again will extend the journey, the distance. So there are many things you can come up with, right? That sort of line of thinking. So very simply, then, why be unlikely to be not unlikely to be accurate? So it's going to be unlikely to be accurate. My answer, anyway, in part A, as the distance would not be a straight line. Would not be a longer straight line, I should say. So it could be curved or something like that, or again they might need to go through multiple roads or multiple journeys because there might be detours or something like that when it goes from A to B. As the distance would not be a longer straight line, so distance would be, so actual distance or real life distance would be greater. Let me rephrase this a little bit. As the engineer would not travel on a perfectly straight line. So the engineer won't travel along a straight line, meaning obviously again he'll be travelling along like roads that are curved, or roads that are longer, or paths that are longer between the points. It's not going to be one straight line, right? Essentially, so the distance would then be greater. Okay. So yeah, you do need to be aware of modelling questions like that, where you need to give a critique of why your answer would not be like realistic, right? What would happen in real life? Don't try and overcomplicate it, right? But hopefully that sort of idea made sense. That like not realistically from one point to another. There's not just gonna be like one straight like road or line or path between them, right? It's gonna be curved. It's gonna be like stuff on the road or something like that, which will extend the journey more than we predict. Okay. Anyway, final exam question then. Let's have a look at this. So figure 1 shows a sketch of a triangle ABC with AB x plus 2, BC is 3x plus 10, AC 7x, and angle BAC 60. And they've drawn the triangle for us again. Quite nice of them. We need to show this quadratic equation, right? Now, again, it looks a bit random. How do we just get this quadratic out of nowhere? But actually, think about it. We've got a triangle with angles and sides, so we can sort of maybe use the cosine rule here, right? So, we have 3 sides and a known angle 60. Why can't we use the cosine rule on that basis then? Well, the opposite angle to 60 is 3x plus 10. So that means 3x plus 10 all squared is going to equal the other two sides squared. So then 7x all squared, add x plus 2 all squared minus 2 times the sides, 7x x plus 2 cosine of 60. So again, I just jumped right into the cosine rule there. I didn't state the formula, I just jumped right into it. Okay, so then I can expand all this. Right, firstly 3x plus 10 all squared. Again, that's not the nicest bracket. You could do it to the side somewhere if you wanted to. So 3x plus 10 of 3x plus 10. And then if you expanded it term by term and do it that way, if it makes it more comfortable. But then you should get, if you expand it, that 3x plus 10 all squared, well, that's going to be 9x squared. And then 3x times 10 will be 30x. Another 30x will be 60x. Then 10 squared is 100. Then 7x all squared is going to be 49x squared. Then x plus 2 all squared, well, that's going to be x squared, add 4x, add 4. Then we've got this bit here. Well, firstly, cosine of 60 is a half. So it's going to be minus 2 times a half of 7x of x plus 2. Okay. Then again, if I collect like terms, well, firstly we're going to have 9x squared add 60x add 100. It's going to equal 49x squared and an x squared would be 50x squared. Add 4x, add 4. Well, then take away, then 2 times a half is just 1. So take away 7x times x plus 2. So I get, well, minus 7x times x will be minus 7x squared. Then minus 7x times 2 will be minus 14x. Okay, then I'm going to then collect all the like terms, right? So I'm going to get, well, 9x squared plus 60x plus 100. I'm going to get 50x squared take away 7x squared be 43x squared. Then I'm also going to have then 4x take away 14x will be minus 10x. And then I have the plus 4. Okay, cool. So that's simplified. Now I just need to move the one side of the equation to the other. So I'm going to move the left side to there. So then 43x squared take away 9x squared would be 34x squared. Then minus 10x minus 60 minus 70x. And 4 take away 100 will be minus 96 equals 0. Cool. Okay, so that's a quadratic equation. Does that match what they've got here? Oh, no, not quite. But I notice that I have 17x squared there as the coefficient for x squared. So that's 17x squared. I've got 34. Well, actually, I noticed that I can divide by 2, right? Because then 34 divided by 17 is 2. So if I divide everything by 2, well, 34 divided by 2 is 17x squared. Then minus 70 divided by 2 is minus 35x. And minus 96 divided by 2 is minus 48. And that equals 0. Is that the equation I got? 17x squared take away 35x take away 48 equals 0. Yes, it is. Cool. So that's part A. So I've shown that equation. So that's the idea, right? If you see like a weird like equation they ask you to show out of nowhere, just work out what you know. What can you work out with the triangle? Well, I know the cosine rule, so I can go from there. Okay, cool. So then the second part there says, hence find the value of x for 1 mark. So I can just use the quadratic formula. So I need to solve for x. So then x is going to be 35 plus or minus square root of minus 35 x squared minus 4 lots of 17 minus 48 over 2 lots of 17 which is going to be, if I put that in the calculator, either x is 3 or x is minus 16 over 17. Well, again, I've got two solutions for x, but x is a length, right? It's part of the length. So that means x has to be positive. Because every length has to be a positive quantity. So if x is positive, then we have to reject the negative solution. So x is only 3. There we are. Cool. That's just for 1 mark. Then we found x then. Then it says, hence find the value of theta. Right. Okay, so we know what x is. Well, again, theta, I can then use the cosine rule again. Because now I know I need to find an angle. But I know all the sides, right? I know what x is. So the opposite, so this angle theta, the opposite side facing it is this x plus 2. But if x is 3, then x plus 2 is going to be 5, right? Likewise, another side, say 7x. Well, that's going to be 7 times 3, which is 21. And then 3x plus 10, well, 3 times 3x is 9, 3 times 3. 9 or 10 is 19. So actually, I've got 3 sides, and I need to find an angle. So that is the cosine rule. So if I restate this triangle down here, hang on. There we are. So ABC 519 ABC, and the other side was 21, was it? Yes. Okay, so now that I've found x, right, x is 3, I can then work out for definite numeric the actual number of all 3 sides by subbing x in. So now I've got all 3 sides, and I need to find the angle theta. Well, that's just cosine rule. Hopefully you can see that. So then again, the cosine rule again. Well, the angle facing the angle is 5. The side facing the angle is 5. So that means then 5 squared is going to equal the other side squared. So 19 squared add 21 squared. Take away 2 times 19, 21, cosine theta. So then we sort of need to solve for theta, right? So I need to get cos theta on its own. So let's evaluate all the numbers, right, on the calculator. Well, 5 squared is 25. And 19 squared and 21 squared is 802. Minus 2 times 19 times 21. That's going to be minus 798 cos theta. So then I can then solve for cos theta, right? So that means 798 cos theta is going to be 802 take away 25. So that's going to be 777. Therefore, cos theta is 777 over 798. So therefore, theta then, if I inverse cos that, I get 13.17 degrees. Does it say to round it to anything? To 1 decimal place, okay. So 1 decimal place, the angle theta is 13.221 dp. Cool then. Okay, so that's cosine rule. As for memorising and knowing the formula, hopefully, I mean, I know it because obviously I've done many questions of it. So it's just ingrained, and hopefully that's probably the best way to remember it for everyone else as well. You could sit there and just memorise it, but I think it kind of naturally gets into your brain when you practice loads of questions with the cosine rule, and becomes sort of just second nature. Okay, yeah, so hopefully these examples have helped. As I say, it's basically GCSE, but it is a bit of a step up with some of the examples, but hopefully it's not thrown you off. Hopefully the examples have helped But yes, that's cosine rule. I'll see you next time.